Alright, so I thought I'd just talk a little bit about the final exam. So I'm going to do it a little bit differently this time around. So what I'm going to do is I'm going to tell you what the problems are in advance. And the idea is that you can work in groups, and I encourage you to work in groups um, and do the research on each of the problems, go back into the code that we've developed over the semester, and put together a script file that you might use to solve the problem. And then what's going to happen is later on in the week, I'm going to publish the data or make the data available. And then at that point, um, I want you to work by yourself. So stop all group conversations and then just download the data, put it into your files, and run your scripts, and hopefully everything will work. Um, so the idea is I want you to think about how to solve these problems in general before you actually solve it with the data. Um, and kind of put together kind of a strategy for how you're going to solve it. Okay, so let's take a look here. So on this part of the exam, so we're going to talk about the problems here in just a second, but just to give you a timeline. So today we're publishing the problems without the specifics, just the general problems. Then Monday through Thursday, I would encourage you to, well, today through Thursday, work in groups, work out templates and examples, do whatever you need to do to get ready for Friday or whenever. Um, I'm going to give you until Sunday, even from Friday to Sunday, to do the work. So Fridays you'll stop all group work and I'll load the data up. And so the hope is that you've prepped well enough by Friday, so that basically you're just downloading the code, running your scripts that you've already prepared, and just publishing the results. Okay, so yeah, what are you going to turn in? You'll turn in something very much like we were doing in the homework. I'm going to get that homework graded and back to you hopefully by Wednesday, um, or yeah, Wednesday. So you'll have an idea of kind of what to expect for the write-up. But it can be fairly short. I'm basically looking for your solution and a summary. So let's take a look at the problems just so we can get a little bit more concrete here. So what's the first problem going to be? Well, the first problem is going to be to build the k-nearest neighbor classifier on some data. And so it'll be about 4,000 points in R22. And so I'm giving you this just so you can be aware of the sizes, the dimensions of your data while you're creating your script file. And the targets are going to be two classes. And so I will give you the two classes, so the targets will be in R2 already. So you don't have to worry about converting like the one-dimensional targets into two-dimensional targets. Um, and then you'll try two different k values, one equal to 2 and one equal to 10, and compare the confusion matrices. So in your script file, right, you'll want to load the data, you'll want to uh, perform the k-nearest neighbor classifier, and then you'll also want to, using the either 2 or 10 centers, or not centers, but neighbors, and then be sure to build that you can build the confusion matrices and display the results. Okay, we've done this before, so it's going to be just a matter of finding where the script files are in your file, whatever your file folder is, and or you can look online for our class. Um, yeah, so let's take a look at the next one. Build an Rbf classifier. So this is going to be the same data set as problem 1, but we'll use k-means initially to set a given number of centers. And I will tell you what number of centers I want you to use, and then construct the Rbf equations and solve it. So what I mean by that is, do you remember what the Rbf equations are? That's the w hat and the phi hat, and then you take the pseudo inverse of phi hat and multiply it by your target matrix. Okay, and then finally create the confusion matrix and present the results. And then I also want you to run the same thing, but just choose the centers at random instead of using k-means, and just compare the results, compare the confusion matrices. Remember, I was telling you before that I found that choosing centers at random was actually a pretty good system. Okay, and just as a note, remember the issue that you had in the homework. Hopefully, you were thinking about how to scale your RBFs, because the results can really depend on how you scale the RBFs. Okay, and so this last problem, I got a little creative. Hopefully, it's not too creative. So this is a neural differential equation. And so suppose that I've got a system of differential equations, probably nonlinear. Um, so like x prime of t equals some function of x, y, and z. Y prime equals f of another function of x, y, and z. And z prime is another function of x, y, and z. So I'm going to go ahead and assume that this is autonomous, although that's not necessary. By the way, I'll tell you that the ODE solver, even though our differential equations will be autonomous, the ODE solver inputs t as well as x. So you'll have to remember that when you're writing your function. Okay, and so the idea here is that I don't know what my differential equation is, the formula for f. All I know is my data. I've got a bunch of data in a data file, and I need to figure out what the f of x is. And so the idea here is going to be that we're going to replace the function f of x by a neural network. So the neural network will take in x and output the derivative. Okay, so the neural net again will input x and output the derivative. And so the data file that you're going to have, the x values, there's like 1,000 points in R3, and then the output will also be 1,000 points in R3. The output being again x prime, y prime, and z prime for each point. Okay, so the data file will represent the vector field, and so you're going to use a 323 neural network. Not using anything built in. I want you to use our script file. So remember that the script file was using stochastic gradient descent to train the neural net, and so it's going to take a little while to train, but be patient with that. The neural network, once you get your ODE solver ready, then I want you to run an ODE solver, and that one can be built in, either ODE 4.5 in MATLAB or Octave, or RK45 in Python. And so what you're going to do then is solve the differential equation for a given initial value, and then plot your solution curve. Okay, so to prepare for this, I would recommend, I'm just making up a three-dimensional differential equation, and then just get some practice running this ODE solver, ODE 4.5 or RK45. And then the second thing that we need to prepare for is how would you build a function file for the neural network, right? So I need a file that represents the neural net, and that's why we're just doing this really simple one, 323. And so the problem here is that the function needs to know what the weights and biases are for your neural net. And so one way to do this would be to just copy and paste the weights and biases from the screen or wherever into your function file. Another way to use is to use global variables. You don't need to use global variables though. Copy and paste works just fine if you want to do it that way. Notice the size of the variables, or the size of your matrices, are going to be fairly big, right? Because you're going to have one matrix going from R3 to R20, right? So that's a 20 by 3, and then another one going from R20 to R3, so that's another 20 by 3 matrix. So yeah, so you're going to have a couple of big matrices there, but then your bias is only in R20 and R3, so that's not too big of a deal. Okay. And then what you want your function file to output, right, is the result of the neural net. So this is very similar to doing the RBF prediction, right, on the given data set. Notice again, I just want to emphasize, right, that the neural network's only really needing to work with x, or x, y, and z, but the differential equation solver wants t and x, so you could just use t as a dummy variable in your neural network function file. It can just be tx, and then you don't have to use t in your function. So, but you do have to have a t in there because the solvers are assuming that t is going to be one of the arguments. Okay, so like I said, I'm giving you the general problem so you can get everything together and ready to go and talk about it with your neighbors. I will answer specific small questions about it, but I don't want to. I'm not correcting anything. I'm not pre-correcting anything, I should say. So I guess I should say, if you don't have a group that you're working with, let me know, and I may make a group out of people who don't have a group. So, because I want everybody to have somebody to bounce ideas off of. Okay. All right. So again, those are the 3 problems for the final exam. Spend a few days thinking about them, putting together some sample script files, so that when I do give you the data, all you have to do is plug in the data and run them, and you're done. Well, you have to write up a little summary too. Okay, that's it. I'll talk to you later.